Okay, quick review. We just set out some rules for making new numeral tokens. You start with any numeral token, add one tally mark, the result is the new numeral token consisting of all the original tally marks plus that new tally mark you just added. And we also made a new symbol, epsilon xy, if and only if numeral token y is the result of adding one tally mark to numeral token x. But what we haven't seen is how this process relates to numeral types. So epsilon xy means numeral token y is the result of adding one tally mark to numeral token x. Epsilon wz would mean numeral token w is the result of adding one tally mark to numeral token z. Now let's assume these two things are true. Remember this guy, definition 1.1? If x is a numeral token, we'll call tau of x its numeral type. If you don't remember what numeral tokens and types are, go back on the playlist and check out that video. So x's numeral type we'll call tau of x. W's numeral type we'll call tau of w. What if x and w have the same numeral type? In other words, what if tau of x equaled tau of w? Well, a numeral token is just an instance of a numeral type, right? Now remember this guy, proposition 1.1. If x and y are numeral tokens, then tau of x equals tau of y, if and only if there are exactly as many tally marks in numeral token x as there are in numeral token y. So if x and w are of the same numeral type, that would mean their numeral tokens have the same amount of tally marks. And notice, saying that they're of the same type doesn't mean they are the exact same numeral token. It means that they have the same amount of tally marks. They can be two different numeral tokens. That is just what a numeral token is, right? It's an instance of a numeral type. One type can have many tokens. So x and w can be two different numeral tokens, but if they have the same type, they're going to have the same amount of tally marks. To give you a real example, let's say the numeral type is 5. So if x and w have the same numeral type of 5 tally marks, then each numeral token is going to have 5 tally marks. What's important here is it's the same amount of tally marks. Now remember, at the beginning of this, we assumed that y is the result of adding one tally mark to x, and z the result of adding one tally mark to w. Epsilon xy and epsilon wz. Well, if that's the case, we've taken the same amount of tally marks and we've added the same amount of tally marks, one to each. So we must still have the same amount of tally marks on both sides. In our example, y has 6 tally marks, z has 6 tally marks. And again, proposition 1.1, if you have the same amount of tally marks, then you must be of the same type. So in other words, tau of y must also equal tau of z. So we could put those together and say, if tau of x equals tau of w, then it must be the case that tau of y equals tau of z. And now we're going to prove the reverse. We're still assuming epsilon xy and epsilon wz. In other words, we're still assuming that y is the result of adding 1 to x and z is the result of adding 1 to w. Now let's assume that tau of y is the same as tau of z. In other words, y and z are of the same numeral type. Again, by proposition 1.1, those numeral tokens y and z must have the same tally marks. And again, being the result of adding 1 to x and w means that x and w must have started out as the same number of tally marks. And again, by proposition 1.1, that must mean that x and w have the same type as well. So tau of x equals tau of w. And we could put that all together to say tau of y equals tau of z, then it must be the case that tau of x equals tau of w. Now notice that we've just realized that the arrow goes both ways here. In other words, tau of x equals tau of w if and only if tau of y equals tau of z. So let's write that down as a new proposition. If epsilon xy and epsilon wz, then it must be the case that tau of x equals tau of w if and only if tau of y equals tau of z. Now why is this important? Well, what have we shown here? Remember that before, all we did was to show how to make a new numeral token from an old one. We didn't say anything about the numeral types. Now we've connected the two, and this means that for any of the same type of numeral tokens, they will yield the same new type of numeral tokens by our process. We had 2 numeral tokens of 5 tally marks each. We epsiloned them, right? We added 1 tally mark to them, and we got 2 new numeral tokens that were of the same type, 6. And we've shown the reverse. 2 tokens of the same type, they must be the result of adding 1 tally mark each to 2 original tokens of the same type.